On October 29, 2018, Lion Air Flight 61 took off from Jakarta, Indonesia, climbed to around 5,000 feet, and then plunged into the Java Sea at nearly 500 miles per hour. All 189 people on board were killed. The flight had lasted 13 minutes. 5 months later, on March 10, 2019, Ethiopian Airlines Flight 302 took off from Addis Ababa, climbed for 6 minutes, and then dove into a field at full throttle. All 157 people on board were killed. Both aircraft were Boeing 737 MAX 8S. Both crashes were caused by the same software system, a system that Boeing's own engineers had flagged as a risk, a system that pilots had never been told existed, a system that was approved by a regulator that had been systematically defunded and pressured to approve it faster. 346 people died. And the question that every investigation, every congressional hearing, and every wrongful death lawsuit has been trying to answer ever since is the same. How does the world's greatest airplane manufacturer build a plane that kills people because the people running it had decided that speed and cost mattered more than the people sitting inside it? Boeing was not always this company. For most of its history, Boeing was the standard against which every other aerospace manufacturer in the world measured itself. It was founded in 1916 by William Boeing, a timber magnate who had learned to fly and decided he could build better planes than the ones he was flying. From that beginning, the company developed an identity built on one principle above all others: engineering excellence. The people who ran Boeing were engineers. The people who made decisions at Boeing understood aircraft. The culture rewarded precision, redundancy, and the willingness to ground a plane until it was right. This was not a marketing slogan. It was a survival imperative. When you build machines that carry hundreds of people 6 miles above the earth at 500 miles per hour, the cost of getting it wrong is not a fine or a lawsuit. It is a field in Ethiopia and a seafloor near Jakarta. That culture produced some of the most consequential aircraft in the history of aviation. The 707 made commercial air travel viable for the mass market. The 747 defined long-haul international travel for half a century. The 737 itself, introduced in 1967, became the best-selling commercial aircraft in history. A workhorse so reliable and so economically efficient that airlines around the world built their entire business models around it. By the time the MAX program began, Boeing had delivered over 10,000 737s across multiple generations. The plane was not just a product. It was an institution. Then, in 2001, Boeing merged with McDonnell Douglas. And that merger did something to Boeing that took 2 decades to fully reveal itself. McDonnell Douglas was a defense contractor with a financial culture, a company where the primary discipline was cost management rather than engineering innovation. When the two companies combined, the McDonnell Douglas leadership, particularly Harry Stonecipher, effectively took control of Boeing's executive culture despite Boeing being the nominal acquirer. The joke that circulated in Boeing's engineering departments for years afterward was that McDonnell Douglas had bought Boeing with Boeing's own money. It was not entirely a joke. Stonecipher famously said that his goal was to run Boeing like a business rather than a great engineering company. The engineers heard that statement exactly as it was intended. The priorities had changed. The balance of power had shifted. Profit margins and shareholder returns were now the primary language spoken in the executive suites in Chicago, where Boeing moved its headquarters in 2001, deliberately separating the leadership from the engineers in Seattle. That geographical distance was also a cultural distance. The people making decisions were no longer in the same building as the people building the planes. By 2010, the cultural shift had produced a specific and catastrophic strategic problem. Airbus, Boeing's primary competitor, had announced the A320neo, a new, fuel-efficient version of their narrow-body aircraft fitted with larger, more efficient engines. Airlines loved it. Fuel is the largest operating cost for any airline, and the Neo's engines promised meaningful savings. American Airlines, one of Boeing's most loyal customers, was seriously considering switching to Airbus. Boeing faced a choice. They could develop a completely new narrow-body aircraft, a clean sheet designed built from the ground up for modern engine technology. This was the right engineering answer. It would take approximately 10 years and cost somewhere between $15 and $20 billion. Or they could take the existing 737 airframe, hang larger engines on it, and call it the MAX. This would take approximately 6 years and cost a fraction of a new design. The financial answer was obvious. The engineering complications were real, but, according to the people making the decision, manageable. Boeing chose the financial answer. The problem with hanging larger engines on the 737 airframe was physical. The 737 sits low to the ground. It was designed in the 1960s for airports without jet bridges, when ground crews loaded luggage by hand, and the low stance was a practical feature. 60 years later, that low stance meant there was not enough clearance under the wings to fit the larger, more fuel-efficient engines that the MAX required without the engines hitting the runway. Boeing's engineers solved this by moving the engines forward and higher on the wing. It worked. The plane flew. But the repositioned engines changed the aerodynamic behavior of the aircraft in ways that mattered at high angles of attack. When the nose is pitched up steeply, as it might be during a steep climb or in an aerodynamic stall. In those conditions, the MAX had a tendency to pitch its nose upward further than the original 737 design, which could lead to a loss of control. Boeing's engineers designed a software system to compensate. They called it the Maneuvering Characteristics Augmentation System, MCAS. MCAS would automatically push the nose of the aircraft down if it detected that the angle of attack was becoming dangerously steep. The system was designed to activate automatically without pilot input and to push the nose down with significant force. If the sensor feeding MCAS was accurate, the system worked as intended. If the sensor was wrong, if it was giving a false reading, MCAS would push the nose down regardless, repeatedly, even if the pilots were trying to pull it back up. There was one sensor, a single angle of attack sensor, no redundancy. In an aircraft where redundancy is the foundational principle of safety engineering, where critical systems have backups, and backups have backups, MCAS relied on a single point of failure. Boeing's engineers knew this. Internal documents that emerged during congressional investigations showed that engineers had raised concerns about the single sensor design. Those concerns were addressed not by adding a second sensor, but by reclassifying MCAS as a less critical system, which reduced the regulatory scrutiny it required. The FAA, which was supposed to be the independent check on Boeing's own safety assessments, had been operating for years under a regulatory framework that delegated much of the certification work back to Boeing itself. The regulator was reviewing Boeing's review of Boeing's own aircraft, and the FAA was chronically underfunded, understaffed, and under political pressure to approve aircraft faster to keep American manufacturers competitive with Airbus. MCAS was not disclosed to pilots in the flight manuals. Airlines were not told the system existed. Pilots flying the MAX had no knowledge of a software system that could override their inputs and push the aircraft's nose toward the ground. Boeing's position, which it maintained through the certification process, was that MCAS was so similar to existing 737 behavior that it did not require additional pilot training. This position was commercially motivated. One of the primary selling points of the MAX to airlines was that pilots already certified on the 737 could fly the MAX without full type rating training, without the expensive simulator time and certification process that a new aircraft design would have required. If Boeing had disclosed MCAS as a significant new system requiring additional training, it would have undermined the core commercial proposition of the MAX program, so they did not disclose it. On October 29, 2018, a faulty angle of attack sensor on Lion Air 61 fed incorrect data to MCAS. MCAS activated. The pilots fought the controls. MCAS activated again. The pilots, who did not know MCAS existed, could not identify what was overriding their inputs. The aircraft dove into the Java Sea. The black box data showed the pilots fighting the controls for the final minutes of the flight. They did not know what they were fighting. 5 months later, the same sequence occurred on Ethiopian Airlines 302. The pilots of that flight had been given a brief notice about MCAS following the Lion Air crash. They followed the Boeing-specified procedure for runaway trim. It was not enough. The aircraft was moving too fast. The aerodynamic forces too strong. They could not recover. The field near Addis Ababa received the aircraft at full throttle. After the second crash, aviation regulators around the world grounded the MAX. The FAA, under enormous pressure and with its own credibility at stake, waited 4 days after the Ethiopian crash before following suit. A delay that drew congressional fury. Boeing's CEO Dennis Muilenburg initially defended the aircraft, suggesting that pilot error was a factor. He continued receiving his full compensation package. Boeing's stock fell, but did not collapse immediately. The company's communications team issued statements that described the crashes as a tragedy, while simultaneously working to resist the narrative that the aircraft design was fundamentally flawed. Internal messages obtained by investigators during this period showed Boeing employees referring to the MAX as designed by clowns supervised by monkeys, and discussing how they had been able to avoid telling the FAA about MCAS by reclassifying it. One employee wrote that he would never put his family on a MAX. These messages had been sent years before either crash. Boeing had them and did not produce them voluntarily to investigators. They were obtained through subpoena. The MAX was grounded for 20 months, the longest grounding of a commercial aircraft in FAA history. The financial cost to Boeing was staggering. The company took charges of over $20 billion related to the MAX crisis. Deliveries stopped, production slowed. Airlines that had ordered hundreds of MAX aircraft pursued compensation claims. The reputational damage extended beyond the MAX program, raising questions about every Boeing aircraft in service and about the regulatory framework that had allowed a demonstrably unsafe aircraft to be certified and operated. Dennis Muilenburg was fired in December 2019, 11 months after the second crash. His replacement, David Calhoun, arrived with promises of cultural reform and a return to engineering values. The MAX returned to service in late 2020 after software updates, additional pilot training requirements, and a certification process that the FAA conducted with significantly more direct oversight than it had applied the first time. But the problems did not end with the MAX recertification. In January 2024, a door plug blew out of an Alaska Airlines 737 MAX 9 at 16,000 feet, leaving a gaping hole in the fuselage. A child's shirt was sucked out. Nobody died only because the seats adjacent to the hole were unoccupied. The investigation revealed that 4 bolts critical to securing the door plug were missing. Not loose, not improperly torqued, but absent. They had never been installed. The quality control failure at Boeing's Renton facility was systematic. Workers described a culture where production speed targets overrode safety checks, where employees who raised concerns were marginalized, and where the pressure to deliver aircraft on schedule had reconstructed exactly the same dynamic that had produced MCAS. The financial culture had not been replaced by an engineering culture. It had simply waited for the attention to move on. Boeing's stock fell again. Congressional hearings resumed. Whistleblowers came forward. 2 of them died under disputed circumstances before they could testify, one from a sudden infection, one from an apparent self-inflicted wound, and the circumstances drew attention that Boeing's communications team could not manage. By 2024, Boeing was in financial crisis. The company reported a full-year net loss of approximately $11 billion. Its credit rating was downgraded to junk status by multiple agencies. A machinists' strike that lasted 7 weeks halted production and cost the company an estimated $4 billion. The new CEO, Kelly Ortberg, who replaced Calhoun in August 2024, inherited a company with a depleted cash position, a damaged supplier network, a workforce that had lost trust in its own leadership, and a reputation that the 737 MAX program and the door plug incident had jointly destroyed. The stock that had traded at nearly $450 in 2019 was trading at around $150 by early 2025. The Boeing story is not a story about a software bug or a faulty sensor. It is a story about what happens when the people running a safety-critical institution decide that financial engineering is more important than actual engineering. It is a story about a regulator that was hollowed out until it could no longer perform its fundamental function. It is a story about the 20-year consequence of a cultural merger, a merger in which a financial culture absorbed an engineering culture and called it progress. The engineers who built the 707 and the 747 and the original 737 understood something that the executives who designed the MAX program had forgotten. The moment you treat safety as a cost center rather than a foundation, you are not running an aerospace company anymore. You are running a countdown. 346 people are dead. The families have filed lawsuits, attended hearings, and held photographs at congressional testimonies. Boeing has paid fines, signed deferred prosecution agreements, and issued statements about the importance of safety culture. In January 2025, the Department of Justice determined that Boeing had violated its deferred prosecution agreement and moved to prosecute. Boeing entered a guilty plea to a single felony charge of conspiracy to defraud the United States. The fine was $243 million. The families of the 346 victims stood outside the courthouse and said it was not enough. They were right. It wasn't. If you want to understand which industries today are operating under the same dynamic, financial pressure overriding safety oversight, regulators too compromised to perform their function, that is exactly what I track in my newsletter. The link is in the description. And if you want to see what happens when another institution decides that the cost of doing things right is too high, click the videos above.